All right, what was the page? 117, 118? Does that sound about the right vicinity? What kind of questions did you see? Yeah. 12. 12? All right. Taking 12 first. All right, number 12. Someone flip that light switch down. Keep the backlights on, please. Thank you. That one, right? Christian. All right, so I'm going to go ahead and subtract 25 from both sides, so I get that. And just by looking at it, what do you think the answer should be? No. What could I plug in for x to make it equal to 0? 0. Done. There's only one answer on this one. Only one answer. Yeah?
Can you do 15 and 14?
14, 15?
Yeah.
Okay. All right, 14. We got x plus 2 quantity squared is equal to 9. And then also number 15, you said?
Yeah.
3x plus 1 squared equals 49. Okay, these are a smidge different. That's probably what you're asking. We have a quantity that's squared. Okay? If we have a quantity that's squared, what I'm going to do as the first move is I'm going to take the square root of the whole quantity, square root of the whole quantity. Remember, you got a plus or minus. So this cancels out, the square root cancels out the squared, so I just get x plus 2 on the left side, plus or minus, and the square root of 9 is 3. And then from there, I'm going to just subtract 2 from both sides. And remember I said this is two answers? What's negative 2 plus 3? What's negative 2 plus 3?
1.
1. And what is negative 2 minus 3? Negative 5. So those are my two answers right there, 1 and negative 5. 15 is done the same way. I'm going to take the whole square root of a quantity to get rid of the squared part. Make sure you remember the plus or minus. Square root of 49 is? 7. Okay, so then I'm going to go 3x equals negative 1 plus 7 first. Is that okay? What's negative 1 plus 7? 6. And what's negative 1 minus 7? Negative 8. And then divide both sides by 3. So you get x equals 2. And x equals negative 8 over 3. And you can totally leave it as an improper fraction. Anything else you'd like to go over? Yeah. 18. Okay. Would it be okay to add 1 to both sides? So if I add 1 to both sides, I get this. Then what do you think you should do? Divide by 3. Good. So divide both sides by 3. Oops. Still squared. Equals 5. Feel comfortable with that? Now I'm going to take the square root, make sure you have a plus or minus, so your answer actually comes out to plus or minus square root of 5, and you can totally just leave that. Anything else you want to take a look at? We good? Was the no namer in that stack? I couldn't remember. Maybe it's next period that has no namer in it.
This is just
Was there a, oh, you just had that extra one?
Yeah.
All right. That's it? We'll go put this in a safe place in the recycle bin. All right, if you would, make sure your name is on top of that assignment and pass it on forward, please.
Can I just add mine to your file? Yeah.
bless you. Hey, Bob.
Yeah. Is yours blue?
Buddy, you're just doing this yellow one right now, right?
Yes.
Cool. Coming in, bud.
So we run these two of x is the opposite of log 2 to the power of x. Got
Will they work?
it.
Checking the double. All right, friends. Everyone has a copy of the notes? Sound good? Okay, let's go take a look at them. All right, so as we go through and solve these, so this was similar to what we've been working on. This one you have to recognize is difference of two squares. And then you get x equals -2 and x equals +2. Okay, that one could also have been done where I added 4 to both sides down square root. This is one of the ones that we would have multiplied. So we have +10, and we know -2 and -5 would work. And then you're going to factor it, so 2x squared minus 2x minus 5x plus 5 equals 0. Factor out of 2x. Factor out of -5. So then we get x minus 1 and 2x minus 5. And those are still equal to 0. Set them equal to 0, so this gives me x equals 1. And this one gives me 2x equals 5. So then x equals 5 over 2. So that's stuff we've been doing, right? And then the top one, yeah.
What's the like on the far left?
Oh.
The 10 and the minus.
Oh, so because it was factoring. Remember when we factor, multiply the last times the first?
Oh yeah.
That's all I was doing, just kind of a little note to myself on the side.
Do you expect us to go that quick, like in our heads?
I hope getting there.
Okay.
You should see my Algebra 2 class.
Are they fast?
How fast are we factoring?
How fast?
It's like x squared plus 7x plus 12, x plus 3, x plus 4, boom, done.
Yeah.
Are we supposed to know it that quick?
Some kids.
Next year
can,
we will.
but, I mean, for the majority of the part, yes.
We'll get you there. And that is the accelerated track though, so.
Okay.
The CP track, don't worry, it won't be. It'll be like,
Okay. Wait, do you do CP out geometry?
I have taught it, but I'm not slated for next year. I found out you were taking it. I'm like, make sure. I'm just kidding. I'm just kidding. All right, let's move on. So when we get to this kind of problem, we start looking at it and saying, I can't factor. I can't factor. It's not factoring out nicely. Right? Agree? So there's got to be a different way that we can go through these that works. Now, things that we knew about this is because it's a quadratic. We know we could use the -b over 2a. And that gives us the axis of symmetry if we were graphing it. And then we could go plug that number back into the original. That gives us the y part of the vertex. So you get xy of the vertex. And we know about the pattern graph and all those kind of things. But we're trying to solve it. So it's not y equals. We're trying to solve it. It's equal to 0. So there is something called the quadratic formula. Okay? But you remember when I just said, remember when we were finding the axis of symmetry, we used x equals -b over 2a? Remember that?
Yeah.
So the axis of symmetry is like right in the very middle of our parabola, right? Whether the parabola opens up or down, it's right in the middle. Well, take a look what is taking place with this. Right there. So here's my -b over 2a, right? And all I'm doing, I'm just adding something to it, and I'm subtracting something to it. Okay, so that all comes in, and we've seen this before, right? I mean, that's just standard, that's our standard form of a quadratic. Okay? So you're going to hate me for this, but this formula we have to know. You don't have to know it yet, but because we're sing-songy happy people,
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
two people now.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
Like 5 people now.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
And then like 20 people in a mosh pit.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
Okay, so obviously music is a way to allow you to remember things, which I think it's valuable to do it, and that goes along with the song Pop Goes the Weasel. Okay, so this is a formula. It means I plug something in and I get something out. And you have to realize your a value is attached to the x squared term. Your b value is attached to the x term. Your c value is not attached to a letter. So as you go through this is called the quadratic term. This is called the linear term. This is called the constant term. Those are just fancy ways of saying it. Okay? So let's take a look at this. I'm going to copy that. Copy. And move on. So let's paste it here. Okay? So first thing we have to do when we're going to use this equation is it equal to 0? It's equal to 0, so we're good. What is my a value? What's my a value? What's in front of that x squared? 1. What's my b value? Huh? -4. And what's my c value? -2. Do you feel comfortable with the A, B's, and C's, how we just figured it out? Don't forget the sign preceding it. If it's a plus, don't worry about putting a plus with it. But if it is a negative, make sure you have the negative. So we have x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so are there numbers that are in this formula right now? Yeah. Those numbers didn't come from the A, B's, and C's. They're constant numbers that will always take place. Okay, constant numbers happen all the time in math and science. Okay, in science world, the ideal gas log, you have an R value that's 0.0821, and it's always 0.0821. Okay, it's just something that happens in chemistry. It's like, hey, we're using the ideal gas law. Okay, R equals 0.0821. Okay, how do you know that? It's a constant. It always exists. Okay, so let's start plugging things that we know in. So I have x equals negative, and I'm going to put a block here, plus or minus in these squares, we are going to put our values. Okay? So let's see. What value goes here? What letter what did we say it was? B. B. What is B equal to? -4. Oh, I got a negative and a negative right in a row. So that's going to become a positive. What letter goes here? B again, so it's going to be -4. But here I'm going to square a negative. If I square a negative, what happens? Turns positive. This -4 stays as is. What letter is here? It's an A value, which is a 1. Good. Okay, and we're going to multiply these all together. Okay, so let's multiply them. And this is, what value was here? C, which is what? -2. And then down here is what letter?
2.
It's an A value, which is equal to? 1. So does everyone see the black is what's always going to stay there, The red is what we plugged in, yeah.
Okay, so since like it says like you cancel out because of the negatives and all that, do you still put it down negative?
Well, for right now,
But then when you
yes,
solve it,
but it'll start, you'll get to a point where you should be like, oh, I can cancel this. But I just want to let you see. You're all good?
Yep.
You're awesome. All right, so let's start solving this problem. I'm just going to move it down. Let's extend the page, and then I got to move it up a smidge. All right. X equals, what do you think happens here? What does that become? Positive 4. Anyone stuck on that? What does this become? It's squared. What's 4 squared? 16. 4 times 4 is 16. All right, we're going to take one big leap. Ready? Negative 4 times 1. Negative 4 times 1 is what? Negative 4. Negative 4 times negative 2 is what? Negative 4 times negative 2 is what? Positive 8. All over, what does that multiply out to? 2. You feel comfortable with the numbers up there? So some of the negatives are gone, right? That's okay. It's a formula. So there are certain things if you plug in, certain operations will make it go away right away. Because there's a plus minus here, that means there's 2 answers to this problem. So let's start solving this a little bit more. X plus or minus. If I add that together, what do I get? 24, and that's over 2. Now, let's do a little side note. Square root 24 is the same thing as 4 times 6. The reason I'm using 4 and 6 is 4 is my largest perfect square that goes into 24. Agreed? So what's the square root of 24? Or square root of 4, excuse me. 2. So I get 2 square root 6. So I'm going to take 2 square root of 6 is the same thing as root 24. So where I have a root 24, I'm going to plug 2 root 6 in. Okay? We can reduce fractions as long as our 3 terms are all done. I can't reduce outside a fraction to inside a fraction, but this 2 goes into this 4 twice, goes into this 2 once. It doesn't touch that because it's inside, and then we write what we have left. That's now a 2 plus or minus. There's a 1 there, so I get 1 times square root 6, or just square root 6. Whole thing's over 1, so we just have this. That's my answer. There's 2 answers there. Yeah.
Okay, how did you do the whole entire like cross out 2 cross out?
Okay, anything outside the radical, 2 goes into. 2 goes in itself once, 2 goes in itself once, 2 goes into 4 twice. So we're just reducing the fraction.
What if it doesn't go into?
Then you just leave it alone.
Okay.
Okay? This is 2 answers. 2 plus root 6, 2 minus root 6. It's an irrational answer. I can't write it as an exact fraction. Okay? Exact answer is what we want to stick with. This is good. We don't change anything. Notice I wrote all of the pluses and negatives in there for a reason, because it's real easy on this equation when you're dealing with negatives. Just forget stuff. Or you rely on your calculator and you plug on your calculator. You want to know how dumb a calculator is? It does exactly what you want it to do. You tell it to do. So if you go negative 4 squared, it gives you an answer of negative 16. But you know that if you go negative 4 and you square it, it's negative 4 times negative 4, which is 16. So you have to put things, if you're going to use your calculator, make sure you put your numbers inside of parentheses. So if you had negative 4 and you want to square it, you go parenthesis, negative 4, parenthesis, raised to the second, and then it'll square it and give you the correct answer. Okay? So, will this one factor? What 2 numbers multiply to give me 6, add to give me 5? 2 and 3? Okay, so I get x equals negative 2, x equals negative 3. If I did my quad, and I know on here my a is 1, b is 5, c is 6. So if we use x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Do you think it'll work? Heck yeah, it'll work. So I get x is equal to negative b plus or minus the square root of b squared minus 4ac. That's a 6. All over 2a. All right, do the math. Negative 5, plus or minus 5 squared, 25. Negative 4 times 1, negative 4. Negative 4 times 6, negative 24. Over 2. Negative 5, plus or minus. What's 25 minus 24?
1.
1? What's the square root of 1?
1.
All over 2. Okay, oops. Out of room. Okay. Negative 5, or 5 plus 1 is 6. 6 over 2 is, whoops, I lost the negative there. Negative 5 minus 1 is negative 6, so I get negative 3. Negative 5 plus that is negative 4 over 2, which is negative 2. My answers here are negative 3 and negative 2, and they're far different than those two answers right there, aren't they? So the quadratic formula works really nicely, even if it can factor. What's the best way to do it? Honestly, if you're going through mathematics, you have to have the factoring down. Okay, the factoring will help you through it. There are times that the quadratic formula will help you. But I would tell you, if every time you have to do one of these problems, and you went right to the quadratic formula, if it could be factored, you're not going to have enough time. Yeah.
How would you get the negative 6 over 2?
Negative 5 minus 1 is over 2, or negative 5 plus 2, or negative 5 plus 1. I did the math right here. Negative 5 minus 1, negative 6. Negative 6 over 2. Negative 5 plus 1, negative 4.
Oh, you have to do it both ways?
There's two answers. Can I move on? What time are we out of here? Oh, cool. Thank you.
Okay, yeah.
Can I move on? Anyone need more time? Okay. So let's see. It says, hey, try and do this factoring. Okay, let's try to do factoring. So you have 2x squared minus 6x minus 20 equals 0. What's different about those? I made it equal to 0, so I moved the number over. I could factor out a 2 from everything. I could do that. This 2 will not interfere with our answer at all. So then I can see, can I factor this? Well, yeah, this factors to x minus 5, x plus 2. How do I know that? Well, negative 5 times 2 is negative 10. Negative 5 plus 2 is negative 3. Perfect. So my answers to this one are x equals 5 and x equals negative 2. If we use the quadratic formula, we have to remember that my a value is 2, my b value is negative 6, and my c value is actually this one. And you have x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. You watch during our quiz, you're going to hear that. You're going to hear people in class. And then you got the one kid in class going, no. You're like, what is he doing? I don't know. Just let him be. All right, let's plug our values in. I get x equals negative b. What's my b value?
6.
Close?
Negative 6.
Negative 6 plus or minus the square root of negative 6 squared. And we know that negative 6 squared has to be positive, right? Even if our calculator says, no, it's negative 36, must be right this week. No! You square any number that is a negative or a positive, it has to become a positive answer. Yeah, but, no, there's no yeah buts. My a value is 2. My c value is negative 20. Squeeze in there. All over 2 times 2. Do the arithmetic. Do you think people lose one of these negatives from time to time? Heck yeah. Negative 6 is positive 6. Plus or minus. Again, negative 6 squared. It's got to be 36. Yeah, but my calculator. Okay, good. Negative 4 times 2 is negative 8. Negative 8 times negative 20 is positive 8 times 20 is, 8 times 2 is 160. Over 4. Moving down. All right, 6 plus or minus 36 plus 160 is 196 over 4. This is where your calculator would help you out. Square root of 196 is 14, because 14 times 14 is 196. So now it's just going to be a 14. Where did the square root sign go? Well, being I took the square root of 196 and got 14, there's no longer a square root sign. So ready? 6 plus 14. 6 plus 14 over 4. What's 6 plus 14? Huh? 20? So I get 20 over 4. 20 over 4 is? 5. Is that one of the same answers over there? Yeah. What is 6 minus 14? You have $6 in your pocket, you buy something for $14. You still owe? Yeah. You happen to owe $8. So what is 8 over 4? Negative 8 over 4? Negative 2. Is this one of the answers over there?
Yeah.
Hey, which way looked like it was longer?
Quadratic.
Yeah. But the quadratic is a valuable tool if it won't factor for you. And that's something that where you have to start being able to recognize these a little bit quicker. For those of you who come to class with a blank sheet of paper and you try and copy down random answers, like you're picking answers out of an infinite number set, saying, he doesn't know, he doesn't care. No, when I look at your paper and I have like a problem that says 3x squared plus 7x plus 8 equals 0, what's x equal to? And you're like, 19x. No. You're wrong. Do I give you points because you like put a number down? Yeah. But if you didn't, you're going to be goofing up on this stuff. There's some more slides. So we get that one, that one. Cool. Can this one be factored? Well, let's see. 3 times 2 is 6. That's a positive 6. So it's either, they both have to be negative because I have a positive and a negative. What factors of 6 add together to give me 4? Now here's the scary thing. Give me one factor of 6. 2 times 3. What's another one?
1 times 6.
1 times 6. My other class period that I do have, is already nameless. It's like, give me a factor of 6. J! You're right. Now we're using the alphabet. I'm like, oh my gosh. Hey, does 2 times 3 or 1 times 6 add up to negative 4 in any way, shape, or form?
No.
No, so it won't factor. Okay, it won't factor. But you can say, well, my A value is 2, my B value is negative 4, my C value is 3, and X is equal to negative B plus or minus the square root of B squared minus 4AC all over 2A. So I'm going to get negative 4 plus or minus negative 4 squared minus 4 times 2, that's my A value, times C, which is my C value, all over 2 times 2. Negative 4, it's got to be positive. Negative 4 squared, positive 16. Negative 4 times 2, negative 8. Negative 8 times 3 is negative 24 over 4. That actually comes out to negative 8 over 4. What can you tell me about the square root of a negative number? It's a positive number. I cannot take two of the exact same numbers ever to multiply together to give me a negative 4. So what is, or to get a negative 8. So what is the square root of this? This doesn't work. That doesn't work. So we have NRS is what you need to put. That stands for no real solution. Real being the number system. Okay? Square roots of negative numbers don't exist in the real number system. They exist in the complex number system, which is another number system that you'll deal with. Okay? So, this is all I want you to do tonight. I would like you to do page 119, 120. Okay? And I would like you to do 4, 6, and 8. That's all I want you to do. Give me your word. You try all 3 of those problems. You come here tomorrow blank. I'm going to take points away from what you've earned. That's only 3 problems. You can try all 3. Got it? Woo! Good stuff.